This video provides a summary of the procedure detailed in AASHTO T84, specific gravity and absorption of fine aggregate. Aggregate specific gravity is necessary to determine weight to volume relationships. The concepts used in the fine aggregate specific gravity test are similar to that of the coarse aggregate specific gravity test. When performing the fine aggregate specific gravity test, the following safety precautions are required: safety glasses, thermal insulated gloves, long sleeves, long pants, and closed-toe shoes. The following equipment, materials, and supplies are required for conducting fine aggregate specific gravity tests: empty pan, pycnometer, cone, tamping rod, heat gun, oven, fine aggregate sample, scale, and funnel. The mass of a coarse aggregate sample is determined in saturated surface dry, oven dry, and submerged states. These values are then used to calculate bulk specific gravity, SSD specific gravity, apparent specific gravity, and absorption. The following provides a summary of the steps required to determine fine aggregate specific gravity and absorption. Obtain approximately 1,000 grams of fine aggregate material passing the number 4 sieve. Immerse the aggregate in water at room temperature for a period of 15 to 19 hours. Dry the sample to a saturated surface dry condition. To do so, spread the sample onto a pan and stir it occasionally to assist in homogeneous drying. A current of warm air may be used to assist the drying procedure. The air current should not blow the sample off of the pan. Periodically assess whether or not the sample has reached the SSD condition by filling a cone with aggregate. Lightly tamp the aggregate with 25 drops of a metal tamper. Remove loose aggregate from around the outside of the mold and carefully lift the mold vertically. If surface moisture is present, the fine aggregate will retain its molded shape. When the aggregate achieves an SSD condition, it will slump slightly. Once slumping occurs, use a scale to determine the aggregate mass. This is the saturated surface dry, or SSD mass. Determine the mass of the dry pycnometer flask. Calibrate the pycnometer flask by filling it with water to the calibration line. Place the flask on the scale to determine the mass of the flask plus water. Pour the water out of the pycnometer flask and place 500 plus or minus 10 grams of the SSD aggregate into the pycnometer and fill with water to 90% of the pycnometer capacity. Agitate the pycnometer for 15 to 20 minutes to eliminate air bubbles and then determine the mass of the pycnometer. Add additional water to return the pycnometer to its calibrated capacity. Place the flask with aggregate and water onto a scale and record its mass. Remove the aggregate from the pycnometer using excess water to flush all aggregate from the pycnometer. Dry the aggregate in an oven at 100 degrees Celsius until it maintains a constant mass. This indicates that all water has left the sample. Cool the aggregate in air at room temperature for 1 hour. Determine the mass of the dry fine aggregate sample. 4 different masses are recorded during the test. Their common symbols are A equal to the mass of the oven dry sample in air, B equal to the mass of the pycnometer filled with water, C equal to the mass of the pycnometer filled with the SSD sample and water, and S, mass of the SSD sample. These masses are used to calculate the various specific gravities and absorptions using the equations shown on the slide. Note that the quantity of B plus S minus C is the mass of the water displaced by the SSD sample. In the apparent specific gravity calculation, the mass of the SSD sample is replaced by the mass of the oven-dry sample, i.e. A replaces S, which means that water permeable voids within the aggregate are not included, and A plus B minus C is the mass of water displaced by the oven-dry sample. The ratios given in the equations are then simply the ratio of the weight of a given volume of aggregate to the weight of an equal volume of water, which is specific gravity. Absorption is calculated as the difference between the SSD sample mass and the oven-dry sample mass divided by the oven-dry sample mass times 100%.